Hi folks, and welcome back to educator.com. In this mini lesson, we're going to go through the first page of the A+ Physics worksheet on Coulomb's law. And you can find a link to that worksheet down below the video. So with that, let's dive in and look at question number 1. Which graph best represents the electrostatic force between an alpha particle with a charge of +2 elementary charges and a positively charged nucleus as a function of their distance of separation? Well, the electric force is K Q1 Q2 over R squared. Remember, we have this inverse square law as a function of distance. So as things get further apart, we get a smaller electric force, and that goes down as the square of the distance. So our correct answer must be number 1. Number 2, in the diagram below, we have two positively charged spheres, A and B, of masses MA and MB, and they're located a distance d apart. Which diagram best represents the directions of the gravitational force, Fg, and the electrostatic force, Fe, acting on sphere A due to the mass and charge of sphere B? Well, A is going to feel an attractive force to B due to gravity. Gravity only attracts, but because they're both positive, it's going to be repelled due to the electrostatic force, the Coulombic force, Fe. So the answer that shows this best is number 3. Question number 3. What is the magnitude of the electrostatic force between two electrons separated by a distance of 1 × 10⁻⁸ meter? Well, the electric force is K Q1 Q2 over R squared. So that's going to be 9 × 10⁹ Newton meters squared per Coulomb squared, K. Our first charge is the charge on an electron, 1.6 × 10⁻⁹ coulombs. Our second charge is also 1.6 × 10⁻⁹ coulombs, and that's all divided by the square of the distance between them, 1 × 10⁻⁸ meter squared. Therefore, the electric force, when I plug this into my calculator, check it out, I get something right around 2.3 × 10⁻12 newtons. Answer number 3. All right, let's take a look at number 4. Two metal spheres, A and B, possess charges of 1 microcoulomb and 2 microcoulombs, respectively. In the diagram below, arrow F represents the electrostatic force exerted on sphere B by sphere A. Which arrow represents the magnitude and direction of the electrostatic force exerted on sphere A by sphere B? Well, this is just really a Newton's third law problem. If we have a force of A on B to the right at length F, we must have the exact same force in the opposite direction on A, or answer number 1. All right, one more here. Two small identical metal spheres, A and B, on insulated stands are each given a charge of 2 × 10⁻⁶ Coulomb. The distance between the spheres is 2 × 10⁻⁻1 meter. Calculate the magnitude of the electrostatic force that the charge on sphere A exerts on the charge on sphere B. Well, the electrostatic force again is K Q1 Q2 over R squared. So that's going to be 9 × 10⁹ Newton meters squared per Coulomb squared times our charge, 2 × 10⁻⁶ coulombs, and our other charge, 2 × 10⁻⁶ coulombs, all divided by the square of the distance between them, 2 × 10⁻⁻1 meter squared. When I put all that in my calculator, I come up with the value of about 0.9 newtons. All right, hopefully that gets you through page 1 of the Coulomb's Law worksheet without any problems. If you struggled there a little bit, go back and check the previous video where we talk about the electrostatic force, and if it went great, then you're probably ready to move on to AP level questions. Thanks so much for your time, everyone, and make it a great day.